Hello everyone, my name is Surya Pothuri and I'm here to represent my team. So we have worked on a project called Identifying Abnormalities in Heart Sound Data using Machine Learning. So our project mainly focuses on the global burden, that is heart disease. So nearly 17.9 million people die every year due to heart diseases. This is because a lot of people doesn't detect it in the earlier stage. So for detecting it in the earlier stage, we need some trained doctors or trained healthcare professionals in order to check your heartbeat and classify it into normal or abnormal. So and we need to have some lot of infrastructure as well. So this all will not be available in every part of the world. So at this time, machine learning can help us. So nowadays we have everyone have phone. So using the phone, you just record your heartbeat, and if you give it to the machine learning model that we have created, it will classify your heart sound into normal and abnormal. But what makes our project stand out from the other projects was we not only focused on the accuracy, but also we focused on the explainability. So our model will give you the explainability like why this heart sound is classified into normal or abnormal. So in this project we have followed a twofold approach. One is using 1D CNN, which is a convolution neural network, and other one is the normal future based machine learning model using traditional machine learning models. So this is the method that we have followed. So using 1D CNN model, that this we have done as a pilot study because we wanted to prove that in clinical sector, the accuracy is not only the factor, but also explainability plays a significant role in it. So let me explain you about our pilot study. So first we have given all the PCG sound recordings to the 1D CNN approach, and it gave us the predictions, and it in predictions gave in this way. We got 94% accuracy by using 1D CNN, which is a good accuracy. But when we added explainability to the 1D CNN using GradCam, we got the output in this way. So you can see this. So it is a output of one of the sample of the data set. So it shows that this red color labeled part is the abnormality found in this heart sound. But if you observe closely, we don't know how it taken the prediction, and there is no explainability like what are the factors that it considered to classify this as normal or abnormal. So this is one of the drawback in convolutional neural networks, because it is a kind of black box kind of thing. So the predictions what it makes we don't know outside. So we have done a parallel study using the feature based machine learning model using random forest, SVM, and XGBoost. So in this we have done pre-processing our dataset. So our dataset consists of 2,400 heart sounds, which are recorded by mobile phone. So in that 2,400 heart sounds, 600 are abnormal heart sounds, and remaining all are normal heart sounds. And we have done some pre-processing to those, and we have analyzed the heart sound signals, and also heart signal analysis we have done. And after doing all the analysis, we have extracted the features from each of the analysis, and we have done some class balancing. As I said, our data set contains 600 abnormal heart sounds and 1800 normal sounds. So really clearly you can observe that there is some class imbalance. So class balancing is mandatory. So we have done class balancing using smart. So I'll be explaining all this in the further presentation. And we have used the machine learning models such as random forest, SVM, and XGBoost. So I will be also explaining why we have taken only these three machine learning models. So coming on to the next slide, I will be explaining you from the basics of our research. So we all know that heart will have four chambers, and blood flows from one chamber to the other chamber through the valves and produces two sounds, that is lub and dub. Lub is also known as S1, dub is also known as S2. So when blood flows from these two through the valves has to be in a good condition. But if there are any defects in the valves, then it may lead to some extra amount of blood may flow from one chamber to the other chamber, or some reduced amount of blood may flow from one chamber to the other chamber. So this may lead to some additional sounds or murmurs. So these may change the pattern of heart sound, like timing, pitch, and intensity. So to measure all these things, we have two main methods, that is ECG and PCG. In this project, we have used PCG recordings because that is very portable. It measures the mechanical heart sounds, and we can record that using the mobile phone, which is very portable. But why we didn't take the ECG recordings was to measure it we need to have electrodes and big monitors. so they are not very portable for our project. So in this project, we have taken PCG, and we have a data set of PCG recordings, which are recorded through the phone. And We have done some pre-processing to all the data set using bandpass filter and wavelet denoising. And we have, from that, we have detected the S1, S2, that is the lub and dub. So the purple ones all are S1, and yellow ones all are S2. So this is the sample of one of the heart sound from the data set. So we have detected this, and from this we have analyzed the heart sound, and we have extracted all the meaningful features such as the average timing between S1, S2, S2, S1, and heart rate variability, such as and all the features that we have extracted. So these all features are clinically trusted. And parallelly, we have also done some heart signal analysis. From that, we have extracted MFCCs, envelope, wavelet features, and all. So these are all the features that we have extracted, and we have organized the data in a CSV format and given to three machine learning models for training and testing. So the three machine learning models are Random Forest, SVM, and XGBoost. These three are different architecture models. That is, Random Forest is a tree-based architecture. SVM is a margin-based architecture, and XGBoost is a boosting-based architecture. So we thought of analyzing how these interpret the heart sound data and give the accuracies and explainability. And as I said, there is some class imbalance between our heart in our data set. Uh, so abnormality heart sounds are very less compared to the normal heart sounds. So to balance it, we use the SMART method, which is clinically tested. Coming to the results, SVM performed 89% accuracy in classification, and Random Forest performed 90% accuracy, and XGBoost performed 89% accuracy. You can clearly observe that Random Forest performed really well compared to all the three machine learning models. And we have also performed K-cross validation, and in this again, Random Forest performed really well compared to the both other machine learning models. And coming to the explainability, so this is the example of one of the heart sound from the data set. So in this, Random Forest predicted this as abnormal heart sound using the explainability features such as zero cross rate, MFCC7. So these are all the features that are affecting the abnormality, and same SVM predicted this as abnormal heart sound using these all features. And XGBoost classified this as abnormal heart sound using all these features. So these are all the features that are affecting the heart sound as abnormal or normal. So this is one of the main asset of our project, that we have included the explainability, and we have explained why the particular heart sound is considered as normal or abnormal, and corresponding to the reason of each feature we have included in our research paper. You can go through it. So coming to the impact on the healthcare, so our project has a lot of impact on the healthcare because we have added the explainability, like why this particular heart sound is classified as abnormal or normal. And using the smartphone, you can just record the heartbeat and give it to the machine learning model that we have created. It will be giving the classification it as normal or abnormal, and it will be also telling you why this sound is classified as normal or abnormal with the features which are trusted by the doctors. And um, and in future, we are going to deploy our project in the mobile phone, and for reliability, probability scores, and safe decision support will be given as a model calibration, and temporal feature localization to connect anomalies with cardiac cycle phases. So these are all the future work that we are going to do, and that's it from our project. So if you have any questions, you're really welcome to ask us. We'll be answering you. Thank you.